Hi, Simon here, GM8NYB. I'm going to continue on with my CR100. I haven't done much in the last month or so with other commitments and whatnot, so I've not really had much chance to sit down and do it. This video I want to try and set up, or show how I set up the IF section and get it set up to the crystal frequency. Now, I recently built this little box here. It's a wobbulator, and I found it in as a design in Practical Wireless from 1987. I was always intrigued with it, and I decided to build it and try it on this. But I've connected it up, and I'll show you in a minute. But it's not very accurate. I don't think it's not going to work for this set, for setting it up. The accuracy of setting the frequency and the actual display on the scope isn't too good there. The original Marconi stuff, they used a ganging oscillator, they called it. Right, there's the display here on the scope. This connection lead here is the output from the trigger. That's your trigger pulse to trigger the external time base, which I've got it connected here. And the other lead is the lead to the output of the detector valve. It's diode 2 in this valve here, and they wanted to connect it underneath, but I couldn't connect it underneath without taking that metal box off. So what I did, I pushed the wire into the socket, then pushed the valve in there. So there is a wire coming out of here, and yeah, it fits in quite nicely there. And then on the end of that, I've got a little 0.1 capacitor just to isolate it, and this has this clip on it, and the clip goes back to the scope, the Y input on the scope there. So the output of the wobbulator goes into the top of the valve here. It's the mixer valve. I can't remember what valve it is now, valve 3 I think. So I just put it onto the top cap there. All the other valves are out apart from the IF valves, and we'll see how it all goes. Of course, I just right. That's the HT turned on. So hopefully we get a display. Right, as you can see, that's the 6 kilohertz bandwidth setting on the. And if I switch the HT off, you see it going up and down there. So it's not a great curve, as you can see. It's not very even. So it's very hard to know what frequency it's actually set to there. And that's I put it down. That's the 3 kilohertz now. You get a better bandwidth there. It's suddenly shot down there. So you've got 2 peaks on either side. I'm not sure what they are. So it's not very accurate there. And there's the 1.2 kilohertz, which is supposed to be able to see the crystal in the response to help tune it in. There's a little, but it's not very accurate there. So by moving the frequency around, you can actually see a little spike on it, but it's not accurate enough. Right. There you can see as you move it about, it sort of silhouettes a bit there. That's an external trigger, and that's just down to the 300 hertz section. It's not very clear. I even turn the amplitude up. It's not good enough really. So there we go, back to the 6 kilohertz. Right, so I shall show you the next method I used, which was using the NanoVna. This is the setup I have now using my NanoVna. The radio's on this side obviously because I need to get access to the inside the bottom cores of the coils, of the IFs, and also the neutralizing capacitor. I've got this lead here is connected to my that's an attenuator there, and just see it here, and that's zoom in a bit through the attenuator and connected up to the VNA here on the red lead there, you can see. So that's the output to the VNA through the attenuator onto the grid of the mixer valve. Right, this is the grid here. Try not to let the thing short out. Now at the bottom here, again, the capacitor is coming from the diode on the detector is fed back to the VNA on channel number, on the second channel there. Is it 221? And then I had it on connected to the PC, a bit of software here called the NanoVna, which is a nice bit of software, and that really gets a better display than watching it on the little screen. I had the VNA, I set it to 465.75, which is what I worked out was the crystal frequency. Not what was written on it was 465.53, but it was nowhere near that. So I think it's aged, something like that. So I tuned up the whole radio to 465.75. Right, now as you can see, this is what I did earlier. This is this is a recorded file I did. There's my crystal. This is 465.75. It's quite a broad peak there. So I just display an old file there, so it's not actually running. Right, just to show you where I set up the IF to. Now the next thing I had to do was tune the whole IF to 165.75. I had to set it up to 465.75 for these the two IFs here. So I'll move off the top cap of this valve here, the IF, and connect up my VNA via the attenuator to the second IF amplifier valve. Now these two here I can tune in to 465.75, which is the center frequency. It's easier to do those two first and then work back to that one, which is the third one. And then these first two here, they are the IF1, which has the neutralizing capacitor, and then there's the second IF here, which has the crystal in it. So the neutralizing capacitor has to be set up at the 1200 kilohertz mark. So that's when it switches in the crystal. For 3000 and 6000, the crystal is not used. So I set it all up to that frequency to start with, and then neutralize it. So put it all back together, and the input back to the mixer valve there. Right, I've set it up now to give us a display of the pass band here. The VNA is connected by the VNA output here is connected to my attenuator, and then from the attenuator, just to lower the input really, the overload, stop it getting overloaded, and the output of the attenuator is connected up to the grid of the mixer valve here. So see what happens. Again, at the bottom, of course, we've got the capacitor on the diode squashed in the edge of that valve, and the output there goes back to the channel 2 of the VNA. Right, as it is set up, I have 465.75 as a center frequency set up here in the top here, Below that I've got 30 kilohertz as a span. Right, I've set this sweep setting to continuous. So I'll click sweep and turn on the HT. Hopefully, takes a while to build up. So that's our 6 kilohertz bandwidth. Spot on the center there. Right, let's reduce it down to 3 kilohertz. Again, 3 kilohertz. Right, now the amplitude is a bit higher. I'm going to reduce the amplitude a little, just to get it at the 0. There we go there. Not too bad. I've stopped it down at minus 70 dBs here. There's the minus 6 dB mark. So that's the point I need to look at. Now on the 3 kilohertz, what I could do here is click Analyze, run analysis. Hang on. Bandpass filter, run analysis, and here I'll put a red mark in the front there. Run it again. Right, start again. Run analysis. Now, here, right. Let's see. So bandwidth minus 6 dB, 3.9 kilohertz. Right, now slightly wider than 3 kilohertz. Now, if you look at the manual, oh yeah, right, gives you the tolerances here. 3 kilohertz. They want 3.5 as the maximum and 2 as the minimum there. So just outside that, probably need to try and get it a bit tighter there if possible. And I also checked the 6 kilohertz one there, and it's just inside the 8. There's about 7 point something. Anyway, so I shall show you how I set it up. I think I'll watch the screen here, and I'll just put it down to the 1200 kilohertz mark, and you'll see where the crystal resonance is. I'll have to off tune it, see what happens there. So just pause that for a second. Right, I'm just about to show the next part of the video of how to set it up, and lo and behold, my VNA stopped working. Now then, it's just putting gibberish on the screen. Sod's law, I suppose. This is what I get on it now. Random lines. I recalibrated it, didn't work, went through the calibration, I reloaded the firmware, and it's still exactly the same. They are very sensitive, those things, electrostatic discharge. I thought I was very careful. I had to go with the attenuator, I had isolated capacitors, and I've had no problems with it generally, until just now, and it's packed up, so I need to get into that, find out. And because it wasn't very expensive, I mean, they are quite, they're over £100, but this was about £80–90. I just opened it up and had a look, and just had a quick look online there, and I think somehow I've got a copy, so it's probably a substandard one. So I'll either try and repair that, or I shall get myself another one. That's the way around it. So unfortunately, that's the end of my showing you how to tune it up, but I can demonstrate roughly what I did. As I say here, these are the coils. Once I set these two up to the 465 the crystal frequency 0.575, got them a nice shape. It's quite wide. I then transferred my input to this valve, so then I got this one in. These were, and I might have to readjust these slightly. And then I got these in. I put it all back together, and I put it on the mixer input. Now then, these coils have these three anyway have adjusting cores at the top, and at the back they have also cores. Now then, if you look at the boot, they have a little, I can find it again, a special tool. So we work out what it exactly was. They call it a ganging tool. You see that it's like a file, and reading the description there. You see this bit here. If you look at those measurements, and I looked at them closely, they measure exactly the same as the flat part on the core adjustments. And you see the section here. All the nuts are loose at the moment. So the very end of here has this little slot in it. And that's a tube that runs all the way down. And then this little section here is a sliding section, a box spanner type thing. Now they're very small, I think they're BA sizes. So instead of trying to make one of these, I improvised. What I've done for the end, I've used this off an old telescopic aerial, and I put it over there and I squashed that end so that fits on quite nicely on these. Oops, can't see that one. A bit closer. You see it there, so it's easy to adjust. Now the nuts underneath, this I think it's 4mm socket worked. Now originally I just undid it like that, but when you tighten them up again, you need to hold the core, so this manages to go inside. So you can hold the core with that, slide that over, and then tighten the lock nuts. I'll try and show some light on the inside of there. Hang on. Okay, this is the underside of the radio here. Now it's hard to see it. I'll point to it with this, but a torch shining on it. So that's IFT5, the coil in there. Hard to get on. And then further along, you've got IFT4. Got a wire in the way. But you see it down the back there. Oops. IFT4. IFT3, which might be easier to demonstrate. Not a tricky thing. Don't forget, this is when you're doing this, it's all switched on. So that's why I insulated the thing there. But I can get that on. Yeah. So that's on. And that's what I use to adjust to here. Just move it a millimetre. I haven't tightened up the nuts yet, so that's I'll try my new device there. So that was under the cores underneath the coils. In the book it says if there are two peaks, use the one that's furthest away from the centre. But I didn't really need to move. Didn't find I had two peaks. I didn't look for it. I just peaked it up. Didn't need much movement, so they were very close. Now the other thing I had to look at is once you've set the IF up to the right frequency, in here, it shows up anywhere. See if I can point to it with a stick. There's a little trimmer capacitor where the end of the stick you see in there. That's in the bottom of IFT1. Now that's called a phasing capacitor. It's on a wind. There's a winding with a capacitor across it, a little tune circuit, and that is switched on the passband switch. But that is only operational when you switch to the 1200 kilocycles. 1200 kilocycles is when they use the crystal. For the 6 kilocycles and 3 kilocycles bandwidths, the crystal is switched out. So it's basically used on the 1200 and the 300. And of course on the 100, but it's the same parameters as the 300. It's just with the 100 switched in, you're using that audio filter on the front. So that was a bit tricky there, but you can get a screwdriver on. I did manage to get a little screwdriver in there, and it has a locking nut on it, but it's still quite tight. I didn't loosen the locking nut, but just careful moving of this. You can see on the 1200 kilohertz, which I wanted to show on a video. Unfortunately, the VNA packed up when I was about to do that. But you can see the crystal peak moving, and you get on one side, or you can flip over to the other side of the peak. Right, I'll go over and look at the ones I did. I stored them up and took snapshots of them, so I'll show you the snapshots of what I got in the end. A snapshot of the 6 kilohertz waveform. That's not too bad there. I'll then see if I can find the 3 kilohertz one. It's quite handy this, because you can I did lots of pictures, different settings. Let's see what that one is. So that's a bit narrow there. And then that's the 3000 kilohertz. I'm not sure if it's showing up very well on this. This is the 0 dB mark. That's -10, -20, -30, -40, -50, -60 dB down. But the half power is what they have is about here. So these are just slightly outside the tolerances of the boot, so it probably needs a little bit more tuning up. I can't do that until I get another VNA or get this one fixed. Right, that's the 1200, and if I rightly, I may have a 300. Now the 300 goes a bit weird. This is the best I could get it there. Right, as you can see, you've got this kink here. Now this kink's down at nearly -40. When I first set it up, this kink was here. This is like a lump, because this is 365.75, which is that peak of that resonant hump on the crystal, and this curve was here, so it came up a spike, and you could actually see the crystal. And as I adjusted the neutralizing capacitor, I got it down to here. Now, continuing adjusting it, obviously it goes round and round in 180 degrees, so that was the best position. As it went past that position, it started to climb back up this edge again. But our -6 dB mark is, I think it's on this time it's slightly too narrow. So it's a bit tricky getting it. You need a bit more playing around with it, I think, and I probably will get it in eventually. But I was going to show on the video this moving up and down as I adjusted the neutralizing one. So then I took pictures. With this, you can compare. I can only compare 2 waveforms. For some reason, you can't put 4 or 5 on at once. So I had to do snapshots. So I'll see if I can find the snapshot somewhere. Now, hard to see. That's the 6K curve. I clicked it to store it, and it's come up rather dark. You can see, I think you can see it there. It's not very good with this camera picking up there on the PC. And there's the 3K. So that's the 6K and the 3K. Right, that's the 3K, and that's the 1.2K. Looks okay to about there, doesn't it? Maybe that's a bit too narrow. And then the last one. Now that's the 1.2, and the 300 is just slightly narrow, so it probably needs a lot of adjusting out there. So that it is pushed this one further down here, this little lump. But that black line there is the 300, and the grey line you can just see here. That's your 1200. Right, these are the curves. I'm trying to move a mouse there. These are the curves from the Marconi IF response curves, the Marconi CR100 manual. Now, obviously, that's the 6K. There's your 3, your 12, and your 300 in there. Now, obviously, these aren't done on these must have been plotted by hand from points. So there may be some artistic licensing getting those smooth curves there. I do get these big differences here between the 300 and the 1200. There is quite a difference here. They're going down to -60 dB as well. There's a -70 dB mark down here. So, but they're looking at the tolerances around the -6 dB, which is even above that. Above this pointer here. Of course, I haven't got them all on 0 there. So that was what I was hoping to achieve. I've not done too bad, very close. Slightly outside the tolerances that's quoted in the book, just by a few hertz, basically. Points of a kilohertz. Like the 3.5 was the maximum for the 3 kilohertz, and I got 3.6. I think I managed 3.7. So it's very close. I might just need a little tighter adjustment. I might have to put one of those valves I haven't got a screen on, so a bit more screening on the valves and put the top caps on, it might help. Plus I'm not sure how good it is using a VNA to what they used. They used a thing called a ganging oscillator. Basically it's a modulated oscillator, a wobbulator really, and obviously and a cathode ray oscilloscope. Well, so that's it really. Just to show you there, this is where I connected onto the diode 2 pin, I think it's pin 5. I put the insulation in there to stop it cutting through the wire. I just poked it into the hole there when I pushed the valve in. They say to remove the screening can underneath, but I've had that screening can off 2 or 3 times when I was trying to repair the BFO, and I didn't really want to disturb it again. Still got to work out this, tie them up as well. That's part of the noise limiter. So that's it so far. It's a bit slow progress in the last while. The next thing is I'm going to have I'm going to get another VNA if I can, or maybe repair this one, and then I'll set it up. We can have another go and get it really spot on with the IF. I'll then put the tuning scale on the front, I think, and I will have to have a look at the alignment of it's going to be a big job, alignment of the coil pack. There's 6 coils in each section. That's 24 coils to align. Maybe not have to align them all, we'll see. To do that I need a plate underneath. There's a calibration plate apparently that had holes drilled in, so I'm going to have a go at making my own calibration plate off a bit of an old washing machine. I'm going to cut the side off it and cut it to shape, drill holes in the right place. Okay, thanks for watching. I hope that was of some use. Sorry about the VNA not working. I was going to show that crystal, how it moved, the crystal curve moved from one side of the skirt to the other as you adjusted the neutralization for the 1200 cycle passband. Okay, I hope that was of interest, and see you next time. Bye bye.